In this section, we'll work on rational expressions. And rational expressions, I like to think of rational numbers. Rational numbers, of course, are numbers that can be written as a ratio of one integer over another, or one integer divided by another. For example, 1/2 is a rational number, or negative 5/3. Those are rational numbers. When we add the term, if we say expressions instead of numbers, then we're broadening the definition to algebraic expressions, or rational expressions will be one polynomial over another polynomial. So an example might be x over 3x minus 5, something like that, or 5 over x squared plus 2x minus 1, or say x cubed minus x squared plus 5 over x plus 2, and so on. So the numerator, the only stipulation is that the numerator needs to be a polynomial as well as the denominator. 5, remember, is still a polynomial. It's a constant polynomial, but so any of these expressions would be rational expressions. I'd like to look at checkpoint 2. It's the first thing we're going to start with, and that is finding numbers for which rational expressions are not defined. And with rational expressions, the only thing you really need to worry about is the denominator. Remember, this fraction bar also means divide. So this would be, we could write this as 7 divided by x plus 5. It would mean the same thing. And as you know, you cannot divide by 0. So the numbers that would have to be excluded from this expression, in other words, numbers that x could not be, would be any number that would make the denominator 0. So you don't divide by 0. So you can set up an equation and solve for it and find the numbers where numbers x that would make the denominator 0. So let's go ahead and set up the equation. X plus 5 equals 0. Subtract 5 from both sides to get x equals negative 5. Whereas in fact x cannot equal negative 5 because that's the number that would make the denominator equal to 0. So that would be the restriction here, or the number that is excluded from the domain. The domain would be any real number except for negative 5. To take another example, here we have x over x squared minus 36. In the numerator we have an x. The numerator can be 0. That's not an issue. So we can ignore the numerator. We need to look at the denominator. This cannot be equal to 0. So let's start by setting it equal to 0 to see and solve to see what numbers actually would make it 0. The different ways you could solve this. I'm going to add 36 to both sides. Take the square root of both sides, and we get x equals square root of 36, or actually plus or minus. When you're solving equations, it could be the positive or negative. And square root of 36 is 6, so x plus, or if x is positive or negative 6, looks like it would make the denominator 0. So those are the two numbers we need to exclude from the domain. In other words, x cannot be equal to 6, and x cannot be equal to negative 6. Or if you prefer, you could just write x is not equal to plus or minus 6.